The fascination of space travel has gripped humanity for generations. The awe-inspiring vastness of the cosmos, the mysterious celestial bodies, and the unending quest for knowledge beyond our earthly confines. Yet the challenge remains. The universe is vast, and even light. The fastest thing we know takes years to travel between stars. This universal speed limit, the speed of light, is a daunting barrier to our cosmic ambitions. In the realm of science fiction, however, there's a concept that often bypasses this universal speed limit: warp speed. It's a staple in stories of intergalactic voyages, enabling our heroes to traverse the cosmos in the blink of an eye. But what if warp speed wasn't just a figment of science fiction? What if there's a scientific concept that could make it possible? Firstly, let's tackle the speed of light, the so-called cosmic speed limit. It's the fastest that anything can travel through the universe, clocking in at an astounding 670 million miles per hour. But why is it considered the ultimate speed limit? Well, according to Einstein's theory of relativity, as an object approaches the speed of light, its energy increases, which in turn increases its mass. This means it would require infinite energy to reach or exceed the speed of light, a feat currently beyond our grasp. The speed of light isn't just a number, it's an integral part of the fabric of our universe, intertwining space and time. And it's not just about speed. It's about how we perceive reality, the passage of time, and the vast distances between the stars. So if we can't break this cosmic speed limit, how could we possibly achieve warp speed? Enter the Alcubierre warp drive, a theoretical concept that may hold the key to warp speed. Named after Mexican physicist Miguel Alcubierre, this idea may sound like it's straight out of a science fiction novel, but it's based on the very real principles of general relativity. To understand the Alcubierre warp drive, imagine you're standing on a moving walkway at an airport. Even if you're not walking, you're still moving forward, right? This is because the walkway, or the space you're on, is moving. Now apply this idea to a spaceship. The Alcubierre drive proposes a method of stretching space in a wave, causing the fabric of space ahead of the spacecraft to contract, while the space behind it expands. In essence, the spaceship would be inside a sort of space-time bubble, and it's this bubble that's moving through space at a speed that could, theoretically, exceed the speed of light. The ship itself isn't moving, but the space around it is. It's a bit like a surfer riding a wave. The surfer, like the spaceship, is carried along by the movement of the wave. The significance of this concept is massive. If we could harness this theory, it could open up the universe for exploration. We could potentially visit distant galaxies that are currently unreachable within a human lifetime. However, it's important to note that this is still very much a theoretical concept. We're not yet able to create the extreme conditions necessary for an Alcubierre warp drive, and there are numerous scientific and ethical challenges to overcome. But it's a fascinating idea that pushes the boundaries of our understanding of the universe. So the Alcubierre warp drive doesn't break the cosmic speed limit, it simply bypasses it. It's a tantalizing prospect, a cosmic loophole that could one day allow us to journey beyond our galaxy and explore the farthest reaches of the universe. But what could this mean for humanity and our exploration of the cosmos? Imagine a future where interstellar travel is as commonplace as hopping on a plane to visit another country. The Alcubierre warp drive could open the door to that reality. This technology, based on the concept of warping the very fabric of space-time, has the potential to revolutionize not just space travel, but our understanding of the universe itself. The implications of such technology are vast and varied. For starters, the Alcubierre warp drive could make the dream of interstellar colonization a reality. Imagine humanity spreading out amongst the stars, establishing colonies on distant planets. We could explore galaxies far beyond our own, uncovering secrets of the universe that we can only speculate about today. Moreover, this could change our perspective on time. With the ability to travel faster than light, we might be able to observe cosmic events as they happened millions of years ago. It's like having a time machine. But instead of going back in our own timeline, we'd be looking back at the universe's past. But let's not forget about the potential for scientific and technological advancements. The research and development required to build a functioning warp drive could lead to breakthroughs in other fields, such as energy generation, materials science, and quantum physics. Yet, the Alcubierre warp drive isn't just about exploring the cosmos. It's about the survival of our species. As Earth's resources dwindle and our planet's health continues to decline, finding a new home amongst the stars could be crucial for the long-term survival of humanity. Still, we must tread carefully. While the Alcubierre warp drive holds immense promise, it also brings up ethical and practical challenges. How do we responsibly explore and colonize other worlds without causing harm? How do we ensure that the benefits of this technology are shared equally and don't become another tool for exploitation and inequality? However, as fascinating as the Alcubierre warp drive is, it's not without its potential pitfalls. We'll delve into these challenges in the next segment. Stay tuned as we continue our journey into the future of space travel with the Alcubierre warp drive. As with any groundbreaking concept, there are hurdles to overcome. And the Alcubierre warp drive is no exception. It's a fascinating concept that promises faster-than-light travel, but it's important to understand the significant challenges that stand in its way. One of the primary obstacles is the requirement for something called negative energy. To put it simply, negative energy is a form of energy that, instead of having positive energy density like the energy we are familiar with, has negative energy density. It's a theoretical concept that is yet to be observed in the universe. Without the existence of negative energy, the Alcubierre warp drive remains a theoretical concept, a tantalizing possibility that is just out of reach. The second challenge is the vast amount of energy required. Even if we assume that negative energy does exist, the Alcubierre warp drive would require an amount of energy equivalent to the mass energy of an entire planet like Jupiter. This is an unimaginably large amount of energy, far beyond what humanity can currently produce. Another challenge is the potential effects on destination points. The warp bubble, as it travels, would accumulate particles and radiation. When the ship decelerates, these would be released in a burst that could potentially devastate the destination. Furthermore, even if we were able to create a warp bubble, controlling it from inside would be impossible with current understanding of physics. The bubble would need to be created and controlled from outside, a problem that seems insurmountable with current technology and understanding. Lastly, there's the issue of causality. If something can travel faster than light, then in some reference frames it can travel back in time. This leads to paradoxes that challenge our understanding of reality, an issue that physicists are still grappling with. Despite these challenges, the Alcubierre warp drive represents a glimmer of hope in our quest to explore the cosmos. It lays the foundation for a future where the stars might not be as out of reach as they seem today. So where does this leave us in our journey to the stars? In this exploration, we've delved into the concept of light speed, a universal speed limit that has long challenged our dreams of interstellar travel. Then we introduced the Alcubierre warp drive, a theoretical solution that could potentially bend the rules of Einstein's relativity. This concept, conceived by physicist Miguel Alcubierre, suggests a way to warp the fabric of space-time itself, creating a bubble that carries a spaceship faster than light. We discussed the tantalizing implications of such a drive. Imagine the possibilities, traversing the cosmos, reaching distant galaxies, and bringing the universe within our grasp. But like any grand idea, it has its challenges. Energy requirements, cosmic radiation, and the creation of the warp bubble are among the hurdles to overcome.